Good day everyone and welcome to your favorite mathematics lesson from Young Brains Academy. My name is JJ Thompson Oladele. Today we are moving to a new topic and that is variation. Before we move further, we want to define variation. Variation is defined as the relationship between two or more quantities such that any change in one affects the other. This can be seen in man's day-to-day activities such as buying and selling. When the price of a commodity changes, then the quantity that be demanded will also change. The price affects the quantity demanded. So any quantity in this relationship, between the two quantities, which is not affected by such changes, is called a constant. What are the types of variation? We have 4 different types of variation. 1. Direct variation. 2. Inverse variation. 3. Joint variation. And 4. Partial variation. Now we want to consider the first type of variation, which is the direct variation. Suppose y varies directly as x. We can write it as y is directly proportional to x. The sign between y and x is the proportionality sign. You can further write it as y equals to kx. By introducing constant k, the proportionality sign will change to equality sign. K is the constant of proportionality. So y equals to kx is the relationship between y and x. Example 1. If y varies directly as x and x equals to 4 when y equals to 12, find 1. The relationship between y and x. 2. Find x when y equals to 18. 3. Find y when x equals to 2. Solution. We want to solve question 1, Roman figure 1. Since y varies directly as x, we can write it as y is directly proportional to x, which also can be written as y equals to kx. By introducing k, we have y equals to kx. We then try to substitute the values of x and y, which are given in the question, into the equation y equals to kx. Then we have 12 equals to 4 times k. Then we divide both sides by the coefficient of k, which is 4. We then have 12 divided by 4 equals 4k divided by 4. Then our k gives 3. That is, k equals to 3. To now write the relationship between y and x, we put in the value of k. We now have y equals to 3x, which is the relationship between y and x. Example 1, Roman figure 2. When y equals to 18, find x. We recall that the relationship between y and x is y equals to 3x. Then we are given the value of y to be 18 to find x. So we try to substitute for y. We have 18 equals 3x. To find out x, we divide both sides by the coefficient of x, which is 3. So we have 18 divided by 3 equals 3x divided by 3. Therefore, our s is equal to 6. Roman figure 3. Find y when s equals to 2. We also recall the relationship between x and y as y equals 3x. We put in the value of x as 2 in order to find our y. So we have y equals 3 times 2, which is the value of x, which is giving us y equals to 6. So the answer is y equals to 6. Example number 2. The time t taken to complete a journey varies directly as the distance d traveled. When distance is 5 kilometers, the time taken is 9 hours. Find 1. The equation connecting t and d. 2. Find the distance d traveled when time t taken is 6 hours. 3. Find the time t taken when distance d traveled is 15. Solution. Question 2, Roman figure 1. Since t varies directly as d, we can write as t is directly proportional to d. By introducing constant k, we then have t equals to kd. After getting this, we substitute for the value of d and t as given in the question. D equals 5, while t equals 9. We now have 9 equals to 5 times k. To find our k, we need to divide both sides by the coefficient of k, which is 5. We then have 9 divided by 5 equals 5k divided by 5. K now gives us 9 divided by 5. We now write the equation connecting t and d by putting in the value of k, which gives us t equals 9 divided by 5d, which is the equation connecting t and d. Roman figure 2. When time t equals 6 hours, find the distance d. Recall that the relationship between time t and distance d is given as t equals 9 divided by 5d, and t has been given as 6 hours. Hence, 6 equals 9 divided by 5d. Then our d is gotten as 6 times 5 divided by 9, which gives us 10 divided by 3. Therefore, the distance covered is given as 3/1/3 kilometers. Roman figure 3. When the distance d equals to 15 kilometers, find the time t. We also recall the relationship between them, which is t equals 9 divided by 5d, and d has been given to be 15 kilometers. We therefore find our t as 9 divided by 5 times 15, which gives 27. The time taken to cover 15 kilometer distance is 27 hours. Before the end of today's lesson, let's consider this practice question. If p varies directly as the square of q and p equals to 20 when q is 5, find 1. The law connecting p and q. 2. Find p when q equals to 8. And 3. Find q when P equals to 12. Thanks for watching. Please follow, like, comment, and share this video. See you next time.